Hey guys, welcome back to the Python preparation session by Uplatz. So we are presenting you few very important Python interview questions. And today we are going to see one very important program in Python for the interview point of view. All right. So many people were asking me to show the working of linear search in Python. So linear search is a kind of searching algorithm, and it's present in every programming language, be it in C, C++, Java, or any language. This linear search is an important interview question. So today in this session, we will see what is linear search, how does it work, and how should we code the linear search program, because few elements in this search are quite ambiguous. The entire program is very easy, but as I told you, few components in this program need to be clarified. They may be little difficult for you when you face interviews. So let's begin. So first, the question will be how to implement linear search. So linear search, as I told you, is a simple, very simple searching algorithm. You will search for a particular value in a collection of items of values, and if the value which you are searching is present, then it's a successful search, else it's a unsuccessful search. Correct? So it's a linear search, and there are many other searching techniques, but linear search is a very simple and easy technique for searching. Okay, so linear search. So why it's called linear search? Because the terms linear means one after the other. Okay, so it is step by step. So linear search means you will you will go on searching element by element in order. You will not start from a random number, you will not jump to a random number, you will not end in a random number. It's not like that. The linear means you will start from the first number itself and go one after the other. You will not skip any number in between, and you finally go to the last number. This is the linear search. Just imagine a real life scenario where you want to search a particular item which you have lost. Okay, so just imagine today morning you have lost something which is very precious for you, and you decide to search it up. Maybe you want to go outside, you want to visit some places and search for the lost item. So you will decide you need to visit locations A, B, C, D, and E. So you need to visit 5 different locations: location A, location B, location C, location D, and location E. So you want to visit these locations in order. So you will start with location A, then go to location B, then C, then D, then finally E. So you want to search your lost item in these locations. And what happens? You are going till the last location, location E, if your item is not found. But imagine if your if you get back your item in location C. Okay, so fortunately you have got back your item in location C. So here in this case, you don't want to visit the remaining locations, correct? So you have got it in location C, but so in this case you don't want to visit the two more locations because there is no use. You have already got it. So similarly, when you want to search an item in a collection of items, you will start from beginning and you are supposed to go till the end. But if you get the item somewhere in the list, somewhere in the collection, now you don't want to go through all the items, right? Because you already got your item back. In this case, you want to come out of the search. So all these things should be taken care of. You don't want to waste your time unnecessarily. Even after getting the lost item, if you visit all the locations, there is no use. So all these things should be taken care of. And ultimately, finally, you will come out of the search. Whether you get your item, whether you don't get your item back, you will come out of the search. In case you get the item, you will come out happily. In case you don't get the item, you will come out unhappily. So this is the difference. But you will come out of the search. This also has to be taken care of. And what is the how can we find out whether you came out happily or unhappily? So this is also a part of this linear search. So all these things you have to remember now. Then when we start the program, I will explain you these three things. The first thing is you want to come out of the search in between if you get the item back, correct? If you don't get the item, you naturally go till the last location. Then the second point, you will come out of the search, maybe happily or unhappily. This is the second point to be remembered. The third point, we need to determine what's the reason you came out of the search, whether you got your item back or you did not get your item back. Because in either cases, in both the cases, you will come out of the search. So let's start the coding. So first we will create a list here, list in Python, to enter some numbers. So here we are creating a list. So list is a collection of items in which you can store values of same type or values of different types. So here for this linear search, you have to store values of same type. Okay, here we have integers and all in some random order 7, 5, 8, 4, 6, 1, 2. Now this is your collection of items. The next thing is you have to enter which number you want to search in this. Okay, So you should enter the key number which you want to search. So we can use the input function. So I will write key equals int input, enter the key value. So key equals int input, enter the key value. Now imagine this step is which number you want to search. Now once this is done, so the linear search, that the actual algorithm will start. So I told you linear search is a fairly simple technique to search. So what we have to do, we have to start from the first number of this list. Okay, we have to start from the first number of this list, visit every number. We will visit one after the other linearly in the list. And then what we do, we compare this particular number, the current number in the list, with the key value. So let's do that. So for I in list, so when I write for I in list, it will start from the first number and it will go through each and every number in the list till the last number. And meanwhile, what I'm doing, if key equals I. So for example, for the first time, I will be 7. So for example, I have entered the key value as 6. So 7 equals 6. Is it true? No, it's not true. Then I becomes 5. So 5, is it equal to 6? No. Then I becomes 8. 8, is it equal to 6? No. So like this, it will compare every number in the list with the key number. Now, when this condition becomes true, So for example, I told you, if you get back your item, you don't want to go till the last location. You want to come out happily, correct? So when this condition becomes true, when key becomes I, I'm using the break keyword. That means I want to come out of the loop. So let's see. So when this condition becomes true, the break keyword will make the loop to terminate. We will come out of the loop immediately. But the next point I told you, we have to determine why did you come out of the loop. So did you come out of the loop happily or unhappily? So for that purpose, I will use a variable here known as flag. So flag is a variable and we are setting this value to 0 now. At the beginning, we are setting the value of flag to 0. And when this condition becomes true, if this condition becomes true, the flag should become 1. It should change its value to 1. Now, we have two possibilities. The value of flag is 0 or the value of flag is 1. So, when will the flag value become 1? That is the main question here. So when, on what condition, the flag will change its value to 1? So when the condition becomes true. So if key equals I, when this condition becomes true, then only the flag value will become 1. For example, here in this list, there is no 10. The item 10 is not there. And I want to search the value 10. Now, this condition will never become true. Key equals I, because 10 is not present in the list. So in this case, the flag value will never become 1. It means the search was unsuccessful. It means you did not get your item back, correct? But if I want to search for 1 in this list, so when when I becomes 1, this condition, if key equals I, becomes true. So only in this case, the flag value will become 1. Okay, so this is the meaning of that. So when I use the break keyword, I will come out of the loop. Now suppose, take the example of 10. The 10 is not present. We will go till the end of the loop. We will come back. Suppose we are searching for 1. So in case of 1, we are not going till end of the loop. We will come out of the loop immediately in between. So in both cases, we are coming out of the loop. But in the first case, we did not get the key number. In the second case, we got the key number. So in the first case, we came out happily. In the second case, we came out unhappily. So if the flag is 0, it means we never found the key number. If the flag value becomes 1, it means we found the key value. So that we are searching here. So if flag becomes 1, if flag is 1, so it means print, the search is successful. If flag equals 1, print search is successful. If correct, so here we are determining whether you came out of the loop happily or unhappily. So if flag equals 1, I will print search is successful. else search is not successful. Okay, let's try it now. So let's save it. So you saw the output, right? Now we will first print the list. So it will first print the list, then you can decide which number you want to search. So 7. So in the first iteration itself, I is 7. So here the key is found in the list. Then now if I want to search 2, yes, it's present. So I have tried to explain linear search in a very simple and useful way. Hope it was helpful. And there is one more task which I have not covered in this. I can leave it to you guys to try it out. So just try to, if the key is found, just try to print the location where it was found. For example, 7 was found in the first location, 2 was found in the last location. Then if the key is not found, try printing key is not found. So the message remains same, but only when the search is successful, you can print the location of where the key was found. Okay, so I'm leaving it to you. It's quite easy. Just try it out. Any doubts, you can mail us. All right. Thank you.